Okay, so here we are with the first lesson of Unit 3. In Unit 3, we're going to be dealing with square root equations, okay, which we saw previously. And so today we're going to start with a little warm-up, but first we're going to start with some stuff that we've kind of already went through. And so in this warm-up, it says solve the following quadratic equations using the quadratic formula. Okay, so just a little recap here. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, and all this is divided by 2a. When we use the quadratic formula, we understand that we are finding basically the x-intercept. So I substitute my values in. So a is equal to, in this case, 1, b is equal to 5, and c is equal to negative 14. Okay, so I substitute those values into this equation, so I get x is equal to minus 5 plus or minus the square root of 5 squared, put it in parentheses, minus 4 times 1 times negative 14. Okay, and this is divided by 2 times 1. Okay, so now I simplify this where I get x is equal to negative 5 plus or minus the square root. Something goes under there, and this is going to be divided by 2. So now I just go to my calculator, I put that information in. So I go 5 squared minus 4 times 1 and times, and that's a negative 14 at the end. Got kind of scruggly. Okay, which gives me an 81. Okay, so I put an 81 under here. So this makes me feel good because now I know that x is equal to negative 5 plus or minus. The square root of 81 is just 9, and then this is divided by 2. And so now I have two different pick another color here. I have two different equations. So I have x is equal to negative 5 plus 9 divided by 2. That's one of the equations. And my other equation is x is equal to minus 5 minus 9 divided by 2. So to get my two solutions, I would just have to solve both of these equations. So when I plug this right here into the calculator, just going to put that little equal sign there. Let me move this over to, okay, try to split them up. Okay, so I'm going to put that little equal sign there, and so over here I'm going to plug in negative 5 plus 9, which gives me 4, and so 4 divided by 2, which is just 2. So this over here is just 2. And then I do the same thing for this. So I go negative 5, this time minus 9, gives me a negative 14. Negative 14 divided by 2 gives me a negative 7. So this should be negative 7. So here are where they cross. Here is where this equation crosses the x-axis. So same thing here. Using a quadratic formula, I go my a value is negative 8. My b value is negative 4. And c is positive 5. Substitute those into the quadratic formula, and I get x is equal to minus negative 4 plus or minus the square root of b, which is negative 4. But I'm going to square it, minus 4 times negative 8 times 5. And this is all divided by 2 times negative 8. Okay, so now I want to simplify this some more, so I go to my calculator, and before I go to my calculator, I'm going to just kind of write it a little neatly. These negatives cancel out, so this is plus or minus the square root of some number, and this is going to be divided by negative 16. So now I'm going to calculate this number under the radical. So that's going to be -4. Got to square it. Minus 4, -8, and then 5. Okay, so I get 176. That goes under here. 176. Now I gotta try to simplify the square root of 176. So just to save time, 176 divided by x to find my factors, so I can break this down. So I go second table. So let's see. I see 11 and 16. So I'm going to use 11 and 16. So this now gives me x is equal to 4 plus or minus 11 and 16. 16 is a perfect square. So this is going to be plus or minus 4 times the square root of 11 divided by -16. Now at this point I can simplify this some more because I see that I have two numbers that can both be simplified, or two fractions that can be simplified, and I'm talking about the whole numbers. So I'm going to quit this, and I'm going to go 4 divided by -16 and hit enter. Gives me a decimal number, so I'm just going to change it back to a fraction, and so I get -1/4. Okay, so this here is going to be equal to x is equal to 1, and then the 4 goes on the bottom, so or that should be -1, sorry, because it's -1/4. So negative plus or minus, then same thing over here. When you divide the 4 and the 16 here, you're also going to get negative. So this is going to be plus or minus, let me fix that, negative square root of 11 divided by 4. Okay, and so you can clean it up a little bit more by just saying that your two solutions are going to be just x is equal to -1 plus or minus, or plus the, or actually minus, let me erase that. Okay, so, and say x is equal to -1 plus a negative, so that's going to change that into a negative. Okay, so instead of writing negative again, I'm just going to write minus the square root of 11 divided by 4, and then my other solution is x is equal to negative, this time minus a minus is going to make a plus, so plus the square root of 11 divided by 4. But in all honesty, I probably could keep it written like this, but I just wanted to show you guys these are your two solutions if you were to graph it. Okay, so let's move on. So in Unit 3, getting started with Lesson 1, we are going to our objective for this lesson. It says students will investigate functions in the form of y equals a times the square root of x minus h plus k. Alright, and just to let you know that this square root is over that h, like that. I meant over the, the h. Okay, so it's like the square root of x minus h plus k, and then you have this little value out here. Alright, so let's go ahead and get started. Alright, so first of all, what we're going to do is we're going to look at the parent function. And so our parent function for any square root function is y equals, let's correct that. Okay, y equals the square root of x. Okay, that is the parent function. All functions have a parent function, so basically this is like where the function begins. So if I go to my graphing calculator in Desmos, which you guys are going to have to do as well, I'm going to graph this function. So I'm going to go y equals the square root of x. And so if I graph that function there, you see where you got this. Now, it says on your your guided notes that you guys need to take a screenshot of this and insert that picture there. So make sure that you guys take a screenshot here. Let me show you. Took a screenshot, and then you're going to take that picture and you're going to insert it inside your document so that you can have it, just like I've done there. Okay, so now we have this function here that's inside our document. So now looking at this function, I see that first of all, I can see just some basic information about it. I can tell this point right here is at 0, 0. So this is like my X and Y intercept right here. So make sure that you understand that because it's at the origin. Now, if I wanted to get table values, let's say that, what if I wanted to know for this function right here, okay, and understand your function as we've discussed previously, understand this is your function that we're looking at, okay, this right here. Y equals the square root of X. So if I want to create a table of values to show on this function, remember we talked about these table of values just being like a snapshot. So for an example, if X was 0, okay, if X was 0, what would my Y be? Well, your Y would be also 0 because you substitute in X everywhere you see an X. And then when you simplify, that 0 will go under there. So like the square root of 0 is just 0. So what if what if X was 4? Then quite naturally your Y would be 2. Well, what if X is, let's think of another clean number. What if X is 9? Then your Y value would be 3. And what if X was 16? Then quite naturally your Y value would be 4. And so if I wanted to plot all of these values on this graph, you'll notice that they'll fall somewhere on top of the graph. So let me show you what I'm talking about. So if I go here and I just create a table of values using Desmos, I'm going to plug these values that I created in. So I created 0, 0. You can see where 0, 0 lie. I created 4, 2. Let's see if that falls. Yep, that's a point that's on that function because it falls directly on there. What about 9, 3? Yes, and what about 16 and 4? Okay, let's see. There you go. So you see all those points that we came up with, they fall on the graph, but this whole graph is not covered in purple. That's why this table of values is just a snapshot or just a couple of points on the graph. But as you can see, there are many, many different points because look at all this red space that I can cover. See, like I told you, I'll be here forever trying to cover all of it. Okay, so now let's take a look at this. All right, what we're going to transition into is to just kind of exploring with various types of square root equations. All right, so here we have a table of square root equations, and the first equation that we have there is y equals the square root of x, and we've already established that y equals the square root of x as being the parent function. So I want to go ahead and graph that. So y equals, and we got the square root of x. Okay, so I put that in my calculator or my Desmos, and I get this function right here. And so now this parent function, y equals the square root of x, is like the basis for all the other functions. Just like your parents when they had you, right? Some of your parents, they gave you blue eyes. Some of your parents gave you brown eyes. Some of your parents gave you round shaped heads. Some of your parents gave you big ears, all that kind of stuff you inherit from your parents. So the rest of these square root functions take on the same shape, okay? Just like you guys took kind of like similar shapes of your parents and similar shades of colors of your parents, they take on similar shapes of a parent function. Now, if this is the parent function, well, this is like our start. So am I going to see any shifts? Not really. Okay, because I want to compare every single function to this parent function. All right, so let's start with the first one. So we have y equals, and I'm going to keep this parent function in there. So we have y is equal to the square root of x plus 5. X plus 5. And all that's under the square root. So now that created this blue function here. Well, what do you notice? Well, if you said, because I'm using this point as my reference point, if you notice that now this point shifted over, it was at 0, 0, now this point is at -5, 0. So it looked like it went over 5 units to the left, okay, if I had to count the number of spaces that it was going over. Now, what do you think caused it to move that way? This 5, well, okay, it didn't move up, it didn't move down anything, it just looked like it moved 5 places to the left. So let's look on our little chart here. You can see, did it shift up or down? No, it didn't shift up or down. Did it shift left or right? Yes. And in this case, it shifted 5 to the left. Okay, and we're going to write L-E-F-T. We're going to write that in there, and I see that it didn't cause it to get narrow, or did it cause it to reflect? It just caused it to shift over. So now I can see that this 5 underneath the square root is going to cause the parent function to shift over 5 or -5 units, or to the left 5 units. So remember that. All right, so what do you think of a negative? What if you think this was -5? What do you think would cause it? What happened? All right, something to think about. So now I'm still going to leave my parent function in there. And now this time I want to compare my parent function to y is equal to the square root of, this time, look what I'm going to put that x, I'm going to put that out there on the outside. So I want to add 5 to it. Oh, so this time the 5 isn't under the square root, it's on the outside of it. And let's look, I took this 0, 0, and it transferred up here. So now it's kind of sitting up there. So what happened? That's right, this 5 on the outside of this function, of the parent function, me adding 5 to the parent function, caused it to just shift up. It shifted up 5 units. So we're going to write that. So I didn't get, let's use a different color. Okay, so it shifted up 5. Okay, and that 5 caused it to do that. Did it shift left or right? No, in this case it didn't. What do you think would cause it to shift left or right, though? Maybe that's something to think about. It didn't reflect, it didn't get narrow, it didn't do anything. The only thing it did was shift it up. All right, now let's take a look at another one. What about the next one? So y is equal to 10 times the square root of just x. Whoa, what do you think that happened there? All right, so some of you guys are like, it looked like it lifted up. So it was like very close to the x-axis, and then it started moving away from the x-axis, right? So it kind of started moving away from the x-axis. So it was down here, then it was up there. So if I look at this number out here, or the difference between these two, I can see the 10 is the only difference. So this 10, it didn't make it shift up, because look at that. It's still at 0, 0. That peak point is still at 0, 0, so it didn't shift up. Let's use a different color. It didn't shift up. It didn't cause it to shift left or right. But did it reflect over the x-axis? No, because if it would reflect it, it would be somewhere down here, almost like a mirror image. So it didn't cause a reflection, but it did cause it to get a little bit narrow or wider. What do y'all think? All right, so we're going to call this, and we're going to say, it kind of, let's call it kind of got a little narrow. Okay, we're going to call this narrow. Made it a little narrow. Alright, so what if you think this number was less than that? What do you think would happen to it? Interesting question. Alright, so now let's take a look at this. So now we're going to compare y equals, no, not x, y. Okay, so y equals the square root of, and I forgot that negative in front of that x. So negative square roots of x. Whoa, what do you think happened? Looks like it didn't shift up or down. It didn't shift left or right. So look at this. It didn't shift left or up or down. It didn't shift left or right. Looks like it's about the same size. They actually look like they're like a reflection. Or it actually almost looks like a U turned over that's created from the different functions. So it didn't make it get narrow, but it did cause it to reflect over the x-axis, where this x-axis looked like our reflection line. So it reflected. Look at that. What do you think caused it to reflect? Yeah, this negative. So now we can say anytime I have a negative out there, I know that I'm going to get some type of reflection. Now for the last one, I'm putting all these things together. So let's see what happens. So I got a negative 10. Sorry, that's y equals negative 10. I put two negatives. Y equals negative 10. And then we got the square root. Then under the square root, we got x plus 5. Then on the outside of the square root, we got just plus 5. Okay, and whoa, what happened? I lost my parent function, huh? That's a plus 5 out there. Alright, so I'm going to put my parent function back in there. So y equals the square root of x. Okay, so what do you think happened? So this is our parent function in blue. And let me swap places. Okay, so this is my parent function in blue. And this is my other function. As you can see, look at there. This point is at now negative 5 and 5. So it looks like it shifted over 5 units and up 5 units. So what do you think caused that? These two negatives. So remember when we had the negative under the square root, it caused it to shift left. Well, it still is going to cause it to shift left. The 5 on the outside of the square root caused it to shift either up or down. So I can come over here and I see some things that's happening. So in this case, we're shifting left, or let's see, we're shifting up 5 units. We're also shifting 5 to the left again. Okay, all this is happening to this one function. Okay, did it get narrow? Yes, it got narrow also. What caused it to get narrow is that 10. Okay, and let's write that 10 beside it so we can remind ourselves that 10 caused it to get narrow. And then, did it reflect? Yes. And what caused it to reflect? That's right, that negative. The negative caused it to reflect. Alright, so now that we've looked at all these things, let's kind of summarize this. So I know if I'm given, let's say, a basic square root equation, and I have some number on the outside, and then it is times some number on the inside, and then some number on the outside, I know that this value here is going to cause it to shift left or right. Okay, and notice I'm saying left or right. Right, I know that this value here is going to cause it to either shift up or down. And I know that this value here is either going to cause it to get narrow or wide. Or it could also cause it to reflect. as we've seen. And what will cause it to reflect? If there was a negative out there, then that would cause it to reflect. Okay, so this is the end of video 3.1, and you guys are going to try some on your own, and we'll come back tomorrow and discuss it.